Okay, today's lesson is going to be two parts. We're going to talk about inverse functions as well as one-to-one functions. So we will be kind of skipping around in your book just a little bit. So take a second to find inverse functions in this first unit. Again, we're going to be skipping around a little bit. Inverses is not something that's new for you. You've talked about inverses in algebra, so this should be somewhat review. And like I said, I'm going to be skipping around. So we are going to kind of slide down to this portion here. All right, so I've got two functions here. I have function f of x and function g of x, okay? If I'm talking about finding the inverse of f of x, what I'm basically doing is I'm taking my function's domain and my function's range and I'm flip-flopping them, okay? So x becomes y and y becomes x. So a way to look at that is if I have the coordinate pair x, y, the inverse of that coordinate pair becomes yx. The domain and the range switch, all right? And again, nothing new here. You've done this before. This is review. So if I have the point negative 3, 5 that lies on the graph of f of x, which of the following points has to lie on the graph of its inverse? Well, we know x becomes y, y becomes x. My domain and range switch. The inverse becomes 5, negative 3. The signs don't change, just the position of the x and y. All right, so inverse functions do have their own special notation, so you have to get comfortable with that. The notation for inverse functions is f to the negative 1 of x. Okay, that doesn't mean an exponent of negative 1. It's function notation for inverses. Okay. So let's take a look at what a graph of an inverse might look like. So I've got my function f of x equals 2/3 x minus 2. It's graphed below. We're going to use the graph to answer some of the questions. Now, again, we know that if we want the inverse of the function, what we do is we take the points and we switch their domain and their range, okay? So if it's easier for us, we can kind of skip down to step C first and graph that function so we can see what that inverse function looks like in order to understand where we're getting the values in part A and part B. All right, so let's do that first. I think it just makes a little bit more sense to do that. So what we're going to do is we're going to take each point's coordinate pairs and take the inverse of them and replot. All right, so I'm going to start with the y-intercept. The y-intercept is currently the point 0, negative 2, which means the inverse is going to have the point negative 2, 0. Here I've got the point negative 1, 2, negative 3. I'm sorry, yep, negative 3. Negative 4, which means I'm going to have negative 4 and negative 3 as a point on my inverse. All right, so now I have 2 so far. This point here is 1, 2, 3, 4, 5, negative 6, negative 6. So that's actually right on my inverse, and that should make sense, and we're going to talk about that in just a second. We've got 3, 0, so 0, 3, which is my new y-intercept. We've got 6, 2, so 2, 6, which is here. So my inverse is this function in blue, and we're going to label f to the negative 1 of x. Okay? So why does this happen? This is really important. Why does the point negative 6, negative 6 not change? Well, obviously the domain and range values are the same, but also if you remember from 9th grade, the inverse of a function is simply the reflection of the line over the line y equals x. So I take my function and I reflect it over the line y equals x. That's the inverse. Why am I reflecting over the line y equals x? We know that reflection takes my domain and my range and switches them. X becomes y, y becomes x. Okay, so again, an inverse is a reflection over the line y equals x. So make a little note of that. Okay. So now it's going to become much easier to evaluate these values. We did this in the last video. If I want f to negative 1 of 2, I'm saying what is y when x is 2? And I'm looking at my blue function instead of my black function. So if I go to my x value of 2 right here, what is my y value? Well, my x value of 2, my y value is 6. Okay, so f to the negative 1 of 2 equals 6. F to the negative 1 of 4. So again, 1, 2, 3, 4. Here's my x value. What's my y value? 1 to negative 3. So that is review from last class. That's nothing new for you. The y-intercept of f to the negative 1 of x, we talked about that. We actually found that value, which we said was 0, 3. Okay. And if you notice, this is 3, 0. The y-intercept is the x-intercept of the inverse function, and vice versa. Okay? It kind of changes spots there. Okay. So we've got a table of values for a simple quadratic function. F of x is our parent function, and we've got the graph. So I've got my x values, my y values. We're going to graph the inverse by switching the order pair. So we're just, from this table, moving this down, we're just changing these values for the domain and the range. Okay. And we're going to replot. So 4, negative 2. 1, negative 1. 0, 0. 1, 1. And 4, positive 2. Okay. So again, what do we notice about this graph of the function's inverse? It is a reflection over y equals x. Okay. We also notice that if I look at this, I know that my parabola is a function, right? Passes that vertical line test. What happens when I pass a vertical line test or a vertical line through my inverse function? Is my inverse of my quadratic a function? No. So the inverse for this function is not a function. And that's going to be important when we start talking about one-to-one functions, okay, or one-to-one relationships. So a function will have an inverse that is also a function if and only if it is one-to-one. That's what we're going to talk about next, okay? So the quick way that we're going to figure that out is whether or not the original function passes a horizontal line test, okay? So if I look at my parent function, if I pass a horizontal line through it, does it cross more than once? If it does, it's not one-to-one, okay? Which means its inverse will not be a function. We're going to talk about that in depth in a minute. Okay, so we are going to have to work backwards in our book here to go to one-to-one functions. So please work backwards. I think it's backwards. Yes, it is. Okay, and go to one-to-one functions for me, please. Okay. Okay, so again, I just kind of said it quick about what one-to-one meant. And one-to-one is an important concept that you're going to kind of have to get straight. What one-to-one means is that if I look at a function, if a function is one-to-one, it means its inverse is also going to be a function. Not every function is one-to-one. Just like we saw with the quadratic, it didn't pass that horizontal line test. It's not one-to-one. Okay? So when we look at mapping, I've got f of x equals 2x, and I've got g of x equals x squared. Okay? If I'm going to map this function, again, f of x is 2x. All right? So negative 2 becomes negative 4, 0, and 4. When I map this, notice it's all pretty one-to-one, right? One element of my domain gets mapped to one element of my range. Now when I go over to a quadratic, my parent function x squared, when I have negative 2 and I evaluate, I get 4. 0, I get 0, and 2, I get 4. Well, 2 elements in my domain are mapping to 1 element in my range. Now, we just talked about this. We said this parent function fails that horizontal line test, which I know means it's not one-to-one. So the other representation of this is 2 elements in the domain are going to 1 in the range. We can't have that happen. Okay? In other words, 2x values have the same y value. Okay? 2x values have the same y value. That can't happen if we want, if we're looking for a function to be one-to-one. Okay. All right. So we're going to look at these tables and decide whether or not they're one-to-one. Again, remember, 2x values cannot have the same y value. So another way to say that is I'm looking to see, are there any repeating y values? If there are repeating y values, it's not one-to-one. Okay. Of the 4 tables below, one represents a relationship where y is a one-to-one function of x. Determine which and explain why the others are not. Okay. So if I look here at my y values, do I have any repeating y's? Well, I've got a 2, a negative 2, 3, and a negative 3. Okay, no repeating here. Let's go over here. A 1, a 0. Well, I've got 2 1s here. So this one is not one-to-one because we've got that repeating y. 2, 4, 8, 16. Well, that one doesn't have any repeating y's either. And then 10, 9, 7, and 10. Well, repeating y. Right? So this is also not one-to-one. So with this one, this value here is my one-to-one function. I think there's a typo here. I think we have a typo. I apologize. Okay. So that's from the table. So again, you're looking for those repeating y's. If we're given a graph, we're going to talk about that horizontal line test. Okay? So if I pass a horizontal line through it, is it going to touch in more than one spot at any point? So here and here, here and here, right? So the first one is not one-to-one, but I guess I should read the directions. Considering the following 4 graphs show a relationship between the vertical line test, the variables x and y. Okay. So circle the 2 graphs above that are functions. Okay. Function means vertical line test. So that passes the vertical. This passes the vertical. We fail here. We fail here. Of the 2 graphs you circled, which one is one-to-one? Well, which one's one-to-one? Horizontal line test, right? Choice 4 is going to be one-to-one. So 1 passes the vertical, which means it's a function, but fails the horizontal, which means it's not one-to-one. Okay, so 4, horizontal line test. Okay. So I want you to do exercise 4 for me and answer it. The question is going to pop up in just a minute, so answer it in Edpuzzle. And we're going to do 5 together. So I'm going to pause here. This question is going to pop up for you. You're going to do it now, and then you're going to put your answer into Edpuzzle. Okay, so the distance that a number x lies from the distance from the number 5 on a one-dimensional number line is given as d of x equals the absolute value of x minus 5. Show an example that d of x is not a one-to-one function. Okay, so basically what I'm looking for in this example that messes me up. It's going to give me two of the same y values when I have different x values. Okay, so if I were to say put in d of negative 5, what would happen? Well, I get negative 5 minus 5, which we know is negative 10, which absolute value is positive 10. Is there another value of x that would give me that same value of 10 if I were to evaluate it? Well, sure. What if I had d of 15? 15 minus 5 gives me 10. Absolute value of 10 is 10. So is this function one-to-one? No. It's not one-to-one. Because I was able to find a counterexample that said if I had two different values of x, they gave me that same value of y. All right, so again, any questions that you may have, please come prepared to class tomorrow with them. Make sure you're answering the questions in Edpuzzle, and I will see you in the morning. Bye.